Hello friends, welcome back to the bench. Our patient is a 1991 Mazda. Let's pull up the ticket. It's 1991 Mazda b2600i. Two-wheel drive with 2.6 motor in it. What's wrong with it? I need a repair of my ECM. I have all the other parts checked and I have narrowed it down to the ECM. The ECM is a replacement of the original. When this ECM was put in the truck, ran great until the other day, about 3 months. So it ran nicely for about 3 months and now it's giving a problem. Now it will start and run, but the engine will misfire at low RPMs and stall, but start back up, rev up to 2000 RPMs, but stall at low RPMs. Finding reliable ECM repair is hard. Yes, that is unfortunately true. So, what is wrong with it? Actually, first when I received it, I was thinking you sent me the wrong board because it's definitely, so the customer said it's definitely misfire due to injector. So injectors are not working correctly. So typically that is the output stage problem, right? This ECM doesn't have output stage inside. The output stage is in separate box. You connect the output stage and that connects to the injectors, which is awesome design, by the way. That's how we used to design our cars and devices in general. Make it modular, and output stage will break, replace the output stage. If the ECM will break, you replace just the ECM, right? Plus the complexity, this is just a two-sided board with components only on one side. There's no components on the back side, and everything is, not everything, most components are through holes, and all of them are pretty much off-the-shelf components, except the Mitsubishi chips, dedicated chips. So, so I was thinking, send me the output stage, but the customer clearly says that it has been narrowed down to the ECM. So I expect they replaced the output stage and there was still problem. Makes sense. As far as how it is controlled, we just have two outputs from the ECM that go to the output stage, and we have two injectors on each line. So the engine is in line, either these two cylinders fire or these two cylinders fire. That's why we have only two signals. It is actually on some Subaru engines, it's the same. We have two wires for injectors and two wires for ignition, and on some you have four wires, depending on the how the engine cycle looks like. And now, what can we do with this? So, thanks to the generosity of the Practical Mechanic. If you don't know the channel, definitely check it out. It's a gold mine of knowledge. But thanks to his generosity, we have the pinout. And the pinout tells us that these two pins are responsible for this. And these two pins can be traced to these two capacitors. And the signal coming from the MCU goes through these two capacitors. Now, why do we have two capacitors on because basically this is the gate of the transistor or base. Most likely this uses bipolar transistors, not field effect transistors, but we don't know because we don't have the board, and it's not like the user manual is gonna, or technician manual, repair manual is gonna tell you exactly what components are being used. It's not something that you should be concerned with. Why do we have those capacitors? That actually is a curious question, because it comes down to, does the current flow through the capacitor? And I would compare it to the question in Java, does the argument passed to the method is passed by reference or passed by value, right? And the correct answer is it's passed by value, but that value is a reference, basically, right? So it's kind of confusing. And the same with because effectively it'll feel like it's passed by reference. If you pass objects, obviously. If you pass primitives, it's purely by value. But the same question with does the current flow through the capacitor? And the correct answer would be no, but physically you're gonna see that it behaves like it, right? So capacitors are in this case are used as a protection. It decouples because physically they're not gonna be connected, right? Capacitor is just two or fundamentally, to simplify it, just two plates that are not touching, right? But they allow the electrostatic potential to build up on the plates of the capacitor. But physically, they're not touching. If you connect the multimeter to the capacitor in the continuity mode, it'll beep for the duration of the capacitor charging, and once it's charged, it's an open circuit, right? Which means capacitors can be used for the either sine wave or basically a signal. Capacitors are wires, but for DC signal, if you just apply voltage, they are open circuits. But for the duration of the capacitor charging, they are like wires. It's because it touches the quantum mechanics. It could be a very complex subject if you really want to be accurate. But as a technician, if someone asks you if the current flows through the capacitor, yeah, sure it does. Sure it does. I can show you. And actually, let me show you. Here we have a circuit. Actually, let me show you the circuit first, right? We have two sources that create a pulse, -5 volts to +5 volts, right? Rise and fall time are 1 microsecond, and it opens for 1 millisecond and closes for 20 milliseconds. So these are just tiny pulses every 20 milliseconds for 1 millisecond. Or every, because 19 milliseconds and 1 millisecond is up. And they connect to two transistors, exactly the same. They connect to the same power source, which is 12 volts, right? 1 kilo ohm resistors, and transistor the transistor 2N2222 that we already talked about, connecting it basically to ground, right? But on the basis of our transistors, we have two capacitors, or one capacitor on each, right? And that will show you the power flowing through this resistor, right? Or the current is roughly 12 milliamps, which is roughly the maximum current, 1 kilo ohm on 12 volts. And we're connected through the capacitor, right? If this was DC, if we just applied DC, then capacitor would charge and there would be no more current flowing through the circuit. The resistor R1 would just experience a slight spike, and that's it, no more current flowing. But take a look at the difference over here. I have 500 microfarads here on the bottom one that allows full current flow, but 1 microfarad on the top one. And as you can see, the top one is barely getting 1 milliamp. So the capacitance of that capacitor makes all the difference. Or there's so if we switch this one from 500 to 400, that would still not make a difference because it's 1 millisecond pulse. But there's the minimum capacitance that the capacitor needs to have to allow 1 millisecond pulse to pass through it fully. If the capacitance is smaller, then essentially half of that pulse is going to make through, or some fraction of that pulse is going to make it through, because capacitor will charge very quickly because the capacitance is low, right? If capacitance is high, then the capacitor will take longer to charge, meaning it will be a wire for a much longer period if it has high capacitance. If it has low capacitance, it's going to allow just tiny pulse to get through. And you can see that may be better on this circuit. Here we have a sine wave, +5, -5. Typical sine wave, right? And if we switch this capacitance to, say, 100 micro, right, and rerun, and check the current on our resistor, it goes to 5 milliamps, right? That's the maximum that it can do because we're doing 5 volts, right, on 1K. But if we now switch it to 10 nanofarads, the current on the resistor dropped to 280 microamps. So you can see the capacitance of this capacitor works kind of like a regulator. It will only allow certain power to pass through it based on its capacitance. Now, why is that important? Why are we talking about this? These are our 2 caps that are on the output, right? Now, what we want to know is the capacitance of them. So again, if this is designed to have 100 nanofarads, or 0.1 micro or 1 micro, if the capacitance drops for whatever reason, that means the power going to the base of the transistor that controls the injector is going to be limited. That's going to result in 2 things. First, the injector is not going to have enough power to open, and it might only partially open or open for a shorter period, not supplying enough fuel into the cylinder. Number 2 result of this is the transistor on the output stage is going to be heating up more than it's supposed to. Now, this might not result in the damage to the transistor because because basically, as long as you have good heat sinks and there's you have something to radiate that temperature into, something that will remove that temperature from the transistor, it'll be fine. So I don't expect the transistors to be damaged because of this, but I will expect that there's not enough power going to the injector. So let's flip it around and catch some focus. Now, these are our 2 capacitors. So if I measure this one, it says nothing. I might need to use the other meter, or okay, this one says 0.7 microfarad, right? 700 nanofarads. This one, on the other hand, now it's saying 0.04 nanofarads. So it's definitely, we don't have enough capacitance here. Now we're measuring in circuit. So first thing, when you want to measure in circuit, Let's see what the resistance is on this one. 155k, so that's good. And on this one is open. And why is it good that it has 150k? I mean, if you want to measure capacitance of the capacitor in circuit, and the resistance between two terminals is, say, 100 ohms, maybe 200 ohms, or maybe 50 ohms, there's no way you're going to be able to measure the capacitance in circuit. If the resistance, on the other hand, is higher, then you will be able to measure relatively reliably. But since we have the resistance, low resistance here, because there should now it's 900k, 950. I'd say that that's fine. That's almost a mega ohm, right? I don't expect anything to be broken because of that. And also we're measuring in the opposite. Let's measure here. Yeah, and it's open line in this way. Because this is kind of a confusing about this one, because they're installed in opposite directions, right? So the input signal goes here and here. Right, that confused me at first. That's why I'm getting different measurements when I measure like this, right? I need to measure like this and like this, right? So there's nothing else wrong. It's just the capacitance of this capacitor on cylinders. Well, 2 cylinders. It doesn't really matter which ones. That means the car will stall because only half of the car, only half of the engine is producing power. Now it will work on higher RPM. Why will it work on higher RPM? Because the engine is turning faster, so that one side can keep up, keeping the engine turning. If the engine is at low RPM, that other half is kind of essential, and that's why it will stall. So that explains it, and this is our fix. Now I just need to locate those capacitors. I don't see anything visually that would indicate that this cap is malfunctioning, but the measurements are saying what the measurements are saying. And we confirmed with the resistance that there is no short or anything like that. So I expect perhaps these transistors are controlling those, maybe. Again, transistors look good. There are no shorts. I don't see anything wrong with the transistors. It's possible that these two perhaps, or these two, are actually controlling, because the signal most likely doesn't come directly from the MCU. There's always some kind of transistor on the output. I mean, in some cases, I've seen that in some cases where the MCU is almost directly connected to the output stage. It happens. When you have IC608, that signal from that signal that comes to the IC608 is coming directly from the MCU, right? So you have the MCU and the output stage, and from the output stage it goes directly to the injectors. So it happens, but in this case, I'm pretty sure we have some intermediate transistors between the MCU and the output stage, most likely. But if this capacitor is not going to have enough capacitance, there's not going to be enough power. That's why it worked well for a while, because the cap was okay, or enough, right? And as it aged, the capacitor lost its capacitance. So that is our fix. I'm not going to fix it now, obviously. because I don't have the replacement. First I need to locate it, but I thought it would be a good opportunity to kind of, you know, dig into the why the capacitance in this case is important. Because I do recapping like these electrolytic caps, right? We have one here and one here, right? When they go flat, the ESR goes high on them, the capacitance go low. That could result in the voltage fluctuations, the voltage drops, mainly voltage drops, because the purpose of this one is just to accumulate the charge. So if more current is momentarily needed, the cap will discharge and deliver that. So essentially, it's a voltage stabilizer. Voltage, yeah, it stabilizes voltage. And not regulator, not to confuse it with the regulator, but it will stabilize voltage. If it goes low, that's usually what happens, or that is what will happen. But that doesn't mean that there's going to be anything visually wrong with the car, meaning that the car is going to misfire or not work or something like that. The cap, even if you completely remove that cap, that will give you like subtle issues, subtle problems, right? That could result, especially with MCUs and all kinds of components like that. The stable supply voltage is very important, because if the voltage drops to a certain level, the MCU might reboot if you're lucky. If you're unlucky, the MCU might find itself in the unspecified state. And basically, you know, like back in the day, remember the computers freezing, right? Mainly because of the power issues, because they consumed a lot of power, and the power supplies had to deliver that power. And as soon as the caps on the power supply suffer from issues, the computer just freezes on you, or basically is unstable. That's why nowadays on the power supplies there's always a PG signal that goes to the motherboard. If the motherboard doesn't receive a PG signal, it will not boot, because it'll assume that there's something wrong with the power supply. And it basically won't works. It will not be stable if there's any issues with the power supply. Alrighty, I think we'll end it here. The customer is in no rush, so that's why I actually received this ECM a while ago, like I think around a week ago. I think on Monday. I received it on Monday, I think. So it's been waiting for its repair a while, and now it's going to be waiting for the capacitor replacement. First, I actually need to find them. I don't expect much issues with this, but that is the repair. Sometimes it's just the caps, even on the ECMs, which is a lot more rare, but sometimes it's just the caps. It's usually on power supplies that it's just the caps. Alrighty, thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.